Peter Kesser. He's the Vice President for Alchemco. He's going to talk about the ITD project report on how to waterproof and protect your bridges for decades. The ITD is a program that TSP2 program put together where they're trying new products, get new products to the market, to the DOTs quicker. So, Peter?
As he said, the ITD task force, it's actually innovative technology demonstration, and it looks at different new materials that are coming into the marketplace, puts them on lawn cycle testing. So I think in our case, they're doing the initial test before the bridge gets waterproofed, and then it's a year, 3 years, and 10 years. They got very specific tests, and you do it in different parts of the country. I think we have to do 10 bridges as part of the setup. It seems like a really good operation. I'm going to be moving through slides pretty fast here. I'm one of these presenters that has a lot of slides and only spends a couple of seconds on each of them. So we're talking about waterproofing protection for highway bridges, and this is long-term waterproofing, as you're going to see as we go through here. So some of this is going to look familiar to you, some of the issues, deck cracking, efflorescence, calcium leaching, longitudinal cracking, spalling, delamination. You know, you're dealing with all of this, certainly the corrosion of the rebar, freeze-thaw issues depending on where you are in the country. And so what are some of the main causes for deterioration in concrete? You've got ACR, you got ASR, carbonation, chloride attack, corrosion, efflorescence, freeze-thaw issues, spalling, water penetration. Those are all pretty much caused by either water and moisture penetration, calcium hydroxide, chloride issues, and or cracks. So that causes everything we just talked about. And the solutions are pretty much in two camps. There's either deck repair and replacement, or there's protection of the concrete to increase the service life. So as many of the other speakers have been talking about, the preventative maintenance side of taking care of concrete. This is not one of the ways to take care of the cracks. We're just going to talk in general here, but our company has a product that is an integral waterproofing system. It's a spray applied, works inside the concrete. We're going to show you a little bit about it. It forms a gel inside the concrete. And so one product is the waterproofing agent. It gets sprayed on, it penetrates into the concrete. The second one is an accelerating agent that helps form this gel, and the gel, it forms inside the concrete about 1/2 to 3/4 of an inch below the surface, and completely waterproofs it. And as I said, it's a long-term waterproofing. There's a cross-section, microscopic cross-section of untreated concrete with all its cracks and fissures and voids and things, and then the right side is the treated once the gel has gotten in there and filled everything in. One of the things that we had just recently was Miami-Dade approval as a roofing product on concrete decks, plaza decks, things like that. And what they did is they poured 2 slabs and encased them, filled them with 2 inches of water on top, and their requirement was that the concrete doesn't leak for 24 hours. I don't know if you can see that or not, but we passed the 24-hour test. We said, let's keep going. They did a 72 hours, that passed. We did 7 days, that passed, and we did 10 days. And at that point, we just said, okay, test over. But it's something that works extremely well. This technology was invented back in the mid-1970s. So there's 45 years of history around the world. Most of it's been in other parts of the globe, not so much in the United States. So this is one of the reasons we acquired this company 4 years ago, because we were so impressed with the technology. It is a chemical reaction, so it takes several days to fill all the cracks and voids and stop the leaks. But it does form gel for several months afterwards, and then it stays resident in the concrete. So when new cracks form, it fills the new cracks as well. 3 things you need to have for this gel to form. You need the waterproofing agent, you need calcium, which is in the concrete, and then you need water. So when a new crack opens up and it lets water in, it hits the waterproofing and it forms new gel. It'll seal up to a 2 millimeter crack, stable cracks at the beginning when it's applied, and then future cracks 0.4, so basically hairline cracks from there on out. Here's a quick video of an application that got done earlier in this summer. I think this one was in Virginia. But if you have a 55-gallon drum and you're spraying out of it, you can put down about 20,000 square feet an hour. It's a pretty fast application. Drying time depends on the ambient conditions, but it's a pretty fast way to get the bridge waterproofed and the lanes back open again. So as we said, integral waterproofing, one of the advantages of it working inside the concrete is it can't be damaged by some of the typical things. For instance, if you're up north, it can't get scraped off by snowplow blades, it's not have UV exposure problems, etc. These products are VOC free. They're NSF 61 tested for water potability, so there's no runoff issues or anything like that. And because it's a gel, it does a nice job with the thermal shock and moving with the concrete structure. So some of the things that make this unique: ability to seal future cracks, proven performance 40 years, quick for traffic to reopen. Our products will have up to a 25-year performance life on them. We've got you'll see here in a second, we've got a 15, a 20, and a 25. So again, as I heard some of the speakers talking about earlier, you know, you've got X amount of money, limited money, too many bridges to take care of. If you only have to go back every 15, 20, 25 years instead of every 5 to 7 years, it makes a big difference over time. And then some of the physical characteristics, as I said, it can't be damaged. It actually densifies the concrete surface. It's resistant to chloride ions, chemicals. It's got really good hydrostatic pressure rating, so it's great for water treatment plants and dams and tunnels and things like that. VOC free, water potable certified. So it's got a lot of good physical characteristics. Fast application means shorter lane closure times. We've got 3 different versions of this. One is a 15-year performance, one is a 20, and one is a 25. The 15-year version is our fastest application. You spray the waterproofing, you let it dry, you water it, you open the lane back up. The other 2, which last 20 years and 25, have an additional step besides the one I just described. Then once that dries, you put crack and void treatment on existing cracks and the accelerating agent, which was that second bottle, and that speeds up the gel formation. The gel formation will happen anyway, it just takes a little bit longer if you don't have the accelerating agent involved. Louisiana DOT did a project in February of 2020. They did it, it was a small area demonstration. They wanted to see how it went, and so they did this with backpack sprayers. You're gonna see this guy spraying with a backpack sprayer. Just to give you an idea of scaling up, this guy can put down about 3,000 square feet an hour with the backpack sprayer. If you pump directly out of the pail or out of the 55-gallon drum, that bumps up to 15 to 20,000 square feet an hour with one person doing it. And again, you can put as many people on that as you want. I've seen people have trailers set up and they'll have a couple of guys going. And to give you an idea, this stuff goes down at about 200 square feet per gallon. That's the coverage rate on it. And then you'll get people that'll have little 4-wheelers or small trucks or something with a spray bar, like a 10-foot wide spray bar. And you know, now you're talking about 30,000 square feet and more per hour. This was an Iowa DOT project. And then South Dakota actually has a box truck with a spray rig that does a lane and the shoulder all at the same time. And we kind of estimated they were probably somewhere over 40,000 square feet an hour. So they were literally spending more time blocking off the lane and reopening than they were doing the waterproofing. We need to have a clean, dry surface for this, so they would have been doing pressure washing in advance of this. And here you see the same truck for South Dakota DOT doing the watering. They just switched spray bars and went one way with the waterproofing and then came the other way with the water truck. So it can be scaled up pretty well. We also get some of the DOTs looking at the concrete barriers, the Jersey barriers. So this can be used on vertical or horizontal applications. This was Delaware DOT, I guess, did this about a year or so ago, year and a half ago, and sprayed the inside and the outside of the concrete barrier and watered it in. There's no safety issue here as far as chemicals. I said VOC free. Because of the water potable certification, you don't have runoff issues or anything like that. The watering can happen any number of different ways. Water trucks seem to be pretty prevalent. You know, if you were in a remote location someplace, you could send a few guys out in a pickup truck, a couple of drums with a drum pump, and you could pump water out of the stream to do the watering if they didn't want to haul a truck all the way out there. So the three different types of waterproofing we have for bridges, the 15-year will seal cracks up to 1 millimeter wide, the 20 years is 1.5 millimeters, and the 25-year is 2 millimeters. So some of the concerns that we get as we're talking to the DOTs and the county engineers around the country, lane closure, time to traffic. So it's very short compared to a lot of the different systems. Life expectancy, up to 25 years. The modulus, is it rigid or flexible? It's a gel, so it's flexible. Will it penetrate microcracks? Yes, it's very viscous. In fact, I'm going to just show you guys here real quick. This is the waterproofing. Yeah, this is the waterproofing agent that you saw there. Clear, colorless, odorless. The accelerating agent. And as you can maybe see, it's already gelling up. If you guys want to see this up close, we've got a booth in there in the middle section and a bunch of these. You can come by and you can see it going through. Preparation requirements, pressure wash and dry. We say very simply, if you can pour water, a cup of water on the deck, if it absorbs in, then our chemicals will absorb in. If there's something on the deck that prevents water from getting in, previous coating, something like that, then that needs to be removed because we need to be able to get into the concrete. Temperature range, it's a 40 degrees and rising like a lot of the construction liquids. And it's relatively low cost comparatively, and let's say very, very fast. And when you start looking at life cycle costing, again, 15, 20, 25 years, it really becomes a winner. So just really quickly, we've been focusing on this now for about 2 years with a variety of DOTs and county engineers, and I think we're up to 14 or 15 states with applications and another 5. There's Washington. Minnesota is actually one of the ones that one of the first ones they did the task force with, so they're actually measuring moisture content, doing core samples, and then again they do that at 3 years, and 1 year, 3 year, and 10 year. Illinois did one, and this gives you a pretty good idea of how this goes out. So on the left, you've got them pre-treating existing cracks. That's what you see on the left there. Then you've got them spraying the entire surface with a backpack sprayer in the middle, and then they're watering on the right there. And as you see, they've got traffic running by on the other lanes. Now, some of the ones, New Jersey DOT had done this for 15 years or so, and they'll actually work under the lights at night, and then in the morning open up the lanes, and there you go. Ohio, I guess that was Ohio, because this is the one I was showing you. Iowa, they really geared up. So this is a drying machine. This has actually flames. It had rained the night before. They didn't want to wait for the deck to just dry out, so they got the truck out there and dried it out. And then they had the 4x with a spray bar, and then you can see there the water tank, and they actually did the deck, and you can see it spraying the barrier as well. And then this is the South Dakota rig that I had showed you. The left side is the spray bar, and the right one is the watering. Oklahoma did one earlier this summer. Delaware, as I had mentioned, they did the concrete barriers. Fort Pitt Bridge, I think that was about 15 years ago as well. Here's the New Jersey DOT one I showed you working at night. They did four of the interstate bridges there. Virginia just did one this year. Arkansas, Louisiana, that's the one we had showed you. And then we've got projects upcoming with those 5. So we're starting to get some traction with the technology. Any of you that are not on this list, we would love to be able to go do a pilot project with you or small projects, and if we can make it part of the ITD task force thing, that would be fantastic, because then the results get shared with everybody as they go along. So that's it. Questions?
So hydrostatic pressure control, you mentioned that. Do you guys have verified numbers you can provide?
We do, yeah.
Pounds per square inch?
Yes.
Positive and negative side?
Yep, we do.
Okay.
And then we've got testing on anything you might think of: depth of penetration, permeability, chloride ion, anything that you want. Again, this is 40 years, so we've tested just about everything.
I have 2 questions. Number 1, when it cures, does it get hot or it stays gel?
It stays gel. It actually reactivates with water. So if there's not water for a long time, it'll actually become a powder, and then as soon as the water hits it, it reactivates into the gel.
So in this case, the strength won't be as good as the concrete, am I right?
Say that again?
The strength of the material, it won't be as good as the concrete.
I would say yes.
Okay, thank you.
So we want to keep
And
on
just to
track.
be clear, this isn't going to prevent cracks from happening. It's just going to waterproof them as they occur.
My question would be, do you have to clean the bridge real well before you apply this, as one question? And 2, have you done any of this like in the west part of the United States where we have fish issues?
You have to clean it well enough so that the pores are open for the material to be able to penetrate in. That's really the litmus test. If water can come in, our chemicals can get in. Yes, we've done, Washington State has done one earlier this year. Oregon's actually bought the materials. I don't think they've applied them yet, but they're also going to be testing here.
Peter, a round of applause. Thanks so much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.